we'll get started in about 30 seconds. But anyways, welcome folks to our Yugabyte Friday Tech Talks. It's a talk by engineers for engineers, and today Shawn is on the call, and we're going to be talking about connection pooling, Spring Boot, and Hikari, right? And using Hikari connection pool with Spring Boot and YugabyteDB. So interesting topic. But before we get started, like Shawn, maybe a quick intro about yourself. If you can tell us just like, really quickly.
Yeah. Hey, my name's Shawn Sherwood. I'm a solution architect here at Yugabyte. Um, and to be quite honest, my background is really deep in app dev, an app dev world. So this has been kind of my passion working at this layer for a lot of my career. So I've had definitely plenty of hands-on experience developing applications and configuring connection pools and doing this sort of thing for some time now. So I'm excited to talk about it.
Fantastic. Fantastic. Look forward to jumping right in. So, folks, welcome once again to the Yugabyte Friday Tech Talks. It's a pretty technical talk. No comments are bad comments, no questions are bad questions. So feel free to ask, keep it interactive. It's more fun for us. If you have a question, just drop it in on the LinkedIn comment box, or you can also later on join our community Slack, yugabyte.com/Slack to, ask questions, and Shawn will answer them there too. So without further ado, maybe let's get it right underway. So,
Okay.
off, Shawn, what do you have for us?
Okay. So the little background, start with a little background as, what is a connection pool? Why do we use it? And specifically when I talk about this is a client connection pool that's part of the application. And the reason is this helps the application to be able to reuse existing database connections. And by using those existing connections, you don't have to go through the whole life cycle, which introduces some delay. So this helps to reduce the overall response time. This is not a new pattern. It has been around a while. But there's been a lot of evolution in the space. There's been a lot of different frameworks that implement connection pools. And really, like I would say that kind of the de facto, at least in the Java ecosystem here, is a Hikari. And what Hikari does, working in like tandem with Spring Boot, is it really manages that connection lifecycle, creating connection, deciding when the connection needs to be expired. Um, and by doing that, it really helps to reduce that churn on the connection creation to the database itself. Um, Hikari is highly configurable. It's very lightweight, very flexible. It's got built-in metrics. So metrics are an important thing to be able to watch and monitor for the health of the application by looking at the connection pool and seeing how effectively it's being utilized. And then really at the end of the day, it's kind of it's essential for any kind of high throughput read write application where you're servicing like web requests on web traffic. There can be some cons. One of the been really since the early days of using connection pools is that the database sees those connections. They look like the same user. They look like a service account instead of maybe looking like the user that actually logged on. So that's potentially one of the downsides. Um, but the other one, which is I'm kind of half and half on this. It could to an application developer that you can kind of obfuscate what's really happening under the hood with the connection management. But as long as you're using a popular solution like Hikari, there's enough documentation, there's enough debugging and logging that you can figure things out, generally speaking. So that's about it. So from a background perspective. Uh, in this context, the demo I'm going to show is a Spring Boot application using Hikari, and specifically orchestrating this with YugabyteDB with our smart driver. Um, but obviously, want to highlight the fact that Hikari is really at the core of this. And Spring Boot is it really this other aspect of it is it's a very powerful, popular framework that kind of out of the box has this built-in support for Hikari. It's been part, I think, of Spring Boot from almost day one for Spring Boot. And in this project that I've developed to kind of show this off, I'm going to show it using Spring Boot auto configuration. with configuration properties.
So
So
Shawn, before we go ahead, Greg has a question. He asks if this is open source and how is the production level support? Some use PG Bouncer connection pool, but that is open source and has some support issues.
yeah, PG Bouncer is not what I would consider a client connection pool. It's more of a server side connection pool. Hikari connection pool is an open source library. It's a Java library that you include into your project, and it becomes the wrapper layer around getting connection to the database and returning connection to the database. So it's really for your application. You bundle it in with your application.
Is it fair to say this is kind of built in into Spring Boot?
It is the default behavior in Spring Boot for a connection pool. You can tell Spring Boot you want to use an other connection pool like DBCP or C3PO, but those are what I would consider more legacy uh, connection pool algorithms. Okay.
All right, great. Thank you.
Okay.
Let's go. Yeah.
Okay. Well, let's just move it into the demo mode. Um, so I have a project that I launched from the Spring Boot start.spring.io. I just went to that specific website. Let me bring that up and show you real quick, where I just selected these dependencies. And the only difference that I have, if we explore this, is that where I had said I can use the Postgres driver, like the vanilla Postgres driver, I'm going to swap that out with our smart driver. So in this case, you can see that I just swapped out the Postgres driver with the Yugabyte driver. And beyond that, it's pretty much a vanilla application uh, with just a simple REST interface that I built off of JPA. And if I were to go and run this, let me move this out of the way. If I go to run this application the first time, um, one of the things that's interesting is what Spring Boot does really underneath the hood is it looks at those classes that are in your class path of the application and decides if there are classes that it knows about. It says, I'm going to try to auto configure them, and it creates instances of those configuration objects in its life cycle with smart defaults, so that creates this really nice experience for a developer running locally. And with this configuration, this application YAML configuration, you can see I don't really have a whole lot here. I've got some extra logging turned on, but I get an error when I start up. Spring Boot tries to give you some decent information about this. It's saying, well, why was it unable to successfully launch? In some cases, it may be able to auto detect what drivers you have on your class path and even do this. And it comes back and tells you, in fact, what I was missing. And it says, really, what you're missing is a data source URL to define what database you're wanting to connect to. And with that said, I do have a database running here on my local. So let's go back and review that. Um, it's here. Nope, here. I have YugabyteD running locally. This is the YugabyteD UI console. I have 3 nodes running on my local environment. And the reason that I'm doing this is I want to be able to simulate an environment where it's a multi-region environment. Here I have a US East, a US Central, and a US West of these 3 nodes running on these ports. So what I'm going to do from the application perspective is see what the driver configuration should look like in order to connect to the database in a vanilla fashion. And this configuration, I'm using another technique within Spring Boot, which is just another profile of a configuration file. So this application.yaml is automatically read by Spring Boot. But if you do another application and this dash, anything that comes after the dash is basically the profile name. So what I'm going to do is when I go to run this, I'm going to edit here in my IDE and activate that one profile. And this is the one data source profile. Um, and you can see that it's just a JDBC URL to that east node on the 5433 port, the Yugabyte white SQL port. I'm telling it what driver to use using this driver class name, and then just the vanilla Yugabyte and with no password. So let's go ahead and run this.
So just to take maybe a 30-second detour as that comes up, like Shawn, like the smart driver versus the regular driver, right? It's just a binary switch. It's pretty easy to compile. Just maybe tell folks, what does the smart driver do in a line or two? No need of detail.
Yeah, it's in fact it is a wrapper around the Postgres driver. You'll hear me say this is the vanilla Postgres driver behavior, and that wrapper provides topology awareness about the Yugabyte environment, which lets you do things like do load balancing across a Yugabyte environment without having to do anything special from a coding perspective, not having to do anything weird at the lower level of the application. Now, without any extra configuration, meaning it's just using the driver without any additional configuration, I get a behavior that is very much like the Postgres driver itself, meaning it's just going to make the connections with Hikari to that one database. And I can kind of prove that if we go back here. I'm going to jump to the performance and live queries, and I'm going to start an Apache bench where I've got 15 threads running against the application now. So once this starts up, I'll be able to refresh and start seeing some of these. And in fact, let's down select this into just seeing the selects. And you can see all the queries are actually being invoked against that east node, that .01. And while this is running,
So what we're seeing here is a list of the live queries against the database. And the first column, which is the node name, it shows that all of it is hitting just a single node.
mm-hmm. So it's just like if you would use the vanilla Postgres driver to connect to Yugabyte. It can only know about the one node.
But internally, the data might be going across all the three nodes in Yugabyte, but the queries are being processed by a single node.
Correct.
All right.
Correct.
Yeah. Okay.
So let me stop this, and I'm going to introduce another configuration here, where this is additive. So I'm going to be using both this data source configuration, and now I'm going to configure Hikari. So the Spring data source Hikari configuration lets me define the pool size and additional data source properties. So these are going to be specific to the Yugabyte driver. So these additional properties are unique to Yugabyte. One of them is being the additional endpoints. So this gives me resilience. So in case that original .1 node is not available, it will fall back to try to connect to either the .2 or .3. It's just comma separated, so as many nodes as you want. Once it comes up, I do want it to load balance. I can say load balance true. And I'm going to actually take off this topology keys real quickly and run this with this configuration and see what happens with this load balance true. So again, what I'm going to do is activate this profile and run the application with both profiles active. And I'll expect that the connection pools that Hikari establishes will now be balanced across all three of the nodes that I have running. So we'll run Apache Bench again, and then we'll go back to this console and refresh it. And indeed, we'll see 1, 2, and 3 here. So with that just one setting, the driver creates connections individually to nodes across the whole topology. So in my simulation, my nodes are east, west, and central, which may not be what you want, meaning you may desire to have your app, if your app runs in the West Coast, you want it to connect to the West Coast nodes. So one way to observe that.
Got it. So to summarize, right, what we did was we had the app connected to a single node with the traditional Postgres driver. And that means all the queries were being sent to that node, irrespective of what happens underneath. And you have three nodes across three regions, but it's using just one node. And the first change you made was to just enable load balance to true using the YugabyteDB data source, the driver. And it automatically started sending data or the queries to all the three nodes because it discovered through the first node what the membership of the cluster was and started doing a round robin. Now, the second thing you're going to do is, because it's multi-region and we might want control as to which regions to send the queries to, you're going to restrict that set and show how you're able to do this. All of this without any code change, right? It's just changing properties in a YAML file.
Exactly. This is just Spring out of the box Spring Boot configuration properties for Hikari and the data source. So what I'm adding now is this topology keys, again, another feature of the YugabyteDB smart driver. And with this symbology of :1, :2, :3, what I'm defining is the driver should connect to any nodes that it finds in the US West 1 that, in this case, I'm putting a star, so any node as its primary source. And if for some reason it can't find a single node that it can connect to in here, this secondary will say fall back to central 1, any nodes in central 1, and load balance across those. And if for some reason the first and second aren't, I could even have it fall back to a tertiary here to east 1. And if I run it now
The
this time,
order of precedence after failure. So first opt for west, and then central, and then east, assuming that the application is running in the west right now.
correct.
Got it. Yeah. And so you can kind of make this follow your application on a region failure or something like that.
Yeah, exactly. And now if I refresh after starting this up, you'll see that my queries are now being executed on this west node, this O3 node.
How can we take a look at why O3 is the west node? Perhaps if you could show us the list of nodes in the cluster. Got it.
Yeah,
So one
O3
is
is the
three,
west.
one is east, two is central, three is west. All right. And if we go back to the live queries, yeah. Got it. And this is going to keep doing that. So maybe let's do one live experiment. I don't know if you're the adventurous kind or a gambling person, Shawn, but let's try to change the order to say we always want to hit the central node first. So
Okay,
so we want to change this to say central is the first option, west is the second option.
okay. So
right.
this time I'll restart it with central as the primary.
Okay. And this is all just on the fly, which is really amazing.
So once that up, start with Apache Bench. And now if we come back here and refresh, you'll see it's
there it is, central.
central. Actually, I could do even one better. Let's since we're trying things live. One other option you could have is say I want west and central.
Mhm.
So let's
Okay.
go in here and define west and central. What I'll do is take this part out and just have the west part, comma, with central part, and I'll just to be clear with this, I'll set that to 2.
Second option. Yeah.
Yeah. So really, you're given a lot of flexibility in defining what nodes, and star is not required. If you wanted to go to very specific zones within a region, you can use it that way. And now we'll see that 2 and 3, the west.
Yep.
So central and west can now be part of it. This may not be a common use case, but again, if you go back to, I can subdivide this into availability zones. You can see this can be very, very powerful.
Yeah, actually, this becomes super useful in the real world between East 1 and East 2.
Yes.
They're relatively close by. And if your other option is central or west, which is far away, then maybe you're okay with East 1, East 2, but not with the third thing. Right? So.
Another thing I wanted to show off was I mentioned about the metrics. I have Prometheus exporter running, and this is scraping Spring Boot Prometheus endpoint. And I can do things like look at the Hikari connections in relative to how many are max and how many are active, and look at that as a ratio and get it to a total percentage. And this can be an important metric to look at the health of your application, because obviously if it starts to go to 80, 90, maybe 100%, you either need to retune the size of your connection pool respective to your app, or use that as an event to trigger an auto scale for your application. So say you get some sort of spike in traffic, and this can be a way of reactively responding once a pool gets to a certain size of activity. Um, there are a few other metrics potentially to watch. This is one other one is just keeping an eye on how long is Hikari taking to require a connection. Um, but this one is probably the important one to me is connections pending. If you have connections pending, what that is telling you is that when a request is coming in, Hikari is actually having to wait for a connection to become available in the pool before it can give it to that request. So this is another metric you could potentially use to trigger an auto scale, and definitely one you'd want to alert on if you did weren't able to auto scale. So that kind of covers the general demo from this perspective. I do have a summary of all these configurations in kind of this one profile that I put together. And I want to talk through at least a little bit of my pattern. And this is a pattern that I've been using pretty consistently with a lot of my deployments. And it's a Spring Boot feature where you can define the property for these configurations and say, if you have an environment variable in your local environment that matches this name, use it. Otherwise, this is your fallback default. And this is really easy to work with when, say, I want to build my application as a container, deploy it to Kubernetes. All I do will override these via config map and then make that config map available to the deployment. So in the target
So
environment, I can override these.
got it. So then like even your example of which ones to fail over to, which region to prefer, all of those could be environment variables, which is quite easy to change and dynamically change even without touching the code or recompiling it. You can just keep those as environment variables and shape it on
Yes.
the fly truly dynamically, right? So
Yeah, exactly. I'll have one build that is my container, but I could deploy that to any kind of environment and override these specific ones. I can use a secrets map to hide the passwords so that those aren't visible immediately. Um, so, so from a overall perspective, there are a few other configurations that I would like to talk about. I kind of alluded to a little bit early on about the minimum and maximum pool sizes. There's quite a bit of information on the Hikari website, on their GitHub that talks about pool sizing. At the end of the day, it's very application specific, but often less is more. I do recommend generally, if it's like a web application, to keep minimum and maximum the same, just so that there isn't time that lags for new connections to be created on a traffic spike. Um, I also like to recommend increasing the max lifetime of the connection. Hikari defaults it to only 30 minutes. And in most environments, there's no reason not to have it last for potentially hours. Um, in some environments, they'll see some infrastructure like networking infrastructure that might kill what it sees as idle TCP connections. And if you use this Hikari Keep Alive, this will send basically a TCP ping on a connection that's idle so that it won't get killed or cleaned up underneath of Hikari. Uh, and then just some vanilla data source properties. Again, Hikari being in charge of the data source, it will configure and provide these other properties to the connection. Some of these are vanilla Postgres driver ones. I do like to recommend making sure that people look at things like setting a socket timeout, because the driver defaults to 0 seconds, which means it never will default or never will time out of the socket. But this is one where if you're running an environment, you've got a pretty tight SLA on response time. You may want to set these types of socket timeouts a little bit more aggressively, as well as a statement timeout. And you can see that my pattern is generally my statement timeout is one that's set to time out the statement on the server before it hits the socket timeout, because that's a little bit cleaner. But if for some reason the statement timeout weren't able to process, the socket timeout's kind of like a global timeout that would stop it.
And these are specific to YugabyteDB because they're the data source properties, right? And a lot of them have the YSQL thing before it. Yeah, got it.
Yeah, these are the last three really are truly the specific ones to Yugabyte. The prepared threshold options, socket timeout, those are all the
Generic to Postgres.
generic. Yes.
Got it.
This prepare threshold, this is another interesting one. People aren't aware of the default in the Postgres driver. It's actually set to 5. And what that means that Postgres will wait till it sees the same prepared statement 5 times before it will properly prepare it on the server side. And in most web applications, that doesn't make any sense. Your application is like the same 20 prepared statements. Why not just let the database prepare it after the very first call anyway? Um, so I think that covers most of what I wanted to talk about. I do have specific slides added in. I'm just going to kind of skip over these because these go over the things that we really already talked about. But if you're interested after the presentation, the slide deck will be available. And then there's some links to some of the specific things that I wanted to talk about there. This project, this little sample project, is available in my GitHub. Feel free to download it or do a fork of it and try it out, because you can do the same thing pretty easily. Set up a local environment and do the same kind of topology changes and experimentation with the driver and the pool. So with that said, thank you, and everybody have a happy Friday.
Awesome. Thanks a lot, Shawn. So first off, we have a couple of minutes. So if someone has questions, please feel free to post them. Again, the discussion is the fun part. But in any case, like I had a couple of questions, Shawn.
Okay.
So the defaults in the Hikari pool, or it could be something, but what are the defaults in Spring when it comes to specifically things like socket timeout, statement timeout, etc. So there's a couple of others, right? So does Spring cover for, like, at the end you want your application to work, right? That's all that matters. So what are the defaults in Spring?
So the defaults in Spring are they don't override many of those properties. In fact, I don't think they override any of them. They give you the ability to override them, but they don't make any additional intelligence on that. I think that's one of the things that when you transition from local development to starting to deploy to your testing environments or your perf test environments, you have to be aware of these settings because Spring doesn't really try to solve them for you. Because I think in the primary reason being is in depending on your app deployment, you need to kind of tune for your own environment.
Makes sense. Yeah, that makes sense. Yeah, so these are some things to pay careful attention to when building an application, because they could absolutely make or break the application.
Yeah. And you may also in your application, you may want to configure 2 connection pools, meaning 2 specific Hikari connection pools, and do different settings on them, because you may have some queries that have a completely different profile where you'll want their timeouts to be completely different than, say, the timeouts that you're going to put where you're servicing web request. Whereas maybe you have other scheduled jobs that run that do cleanups where those may run longer. So you'll have a separate pool configuration just for that type of workload.
Yeah, makes total sense. Martin has a question. Do you recommend using PG Bouncer with YugabyteDB?
Well, I think that's an interesting question, because I think there's some potential drawbacks to using PG Bouncer when it comes to like transactional behavior. But I want to say is the things that we're looking at. I know that there are some features coming in Yugabyte that would be a server side connection pool, which I think will work perfectly fine with Hikari connection pool, meaning this behavior with Hikari should work just fine with that if you need that other server side uh, um, type of pool.
Yeah, so Martin, is exactly as Shawn said. You could use PG Bouncer with YugabyteDB. It's really no different than a set of nodes running Postgres. The Postgres, in this case with YugabyteDB, are aware of each other and know how to distribute data. The disadvantages of PG Bouncer are, firstly, you have to authenticate your PG bouncer to the database, be it YugabyteDB or Postgres, it doesn't matter. And oftentimes the level of control you get, the depth of authentication and security you get is lower between the PG bouncer and Yugabyte or Postgres compared to Postgres or Yugabyte itself. So that's issue number one. Issue number two is you have to keep updating PG bouncer to go after all the nodes in the cluster, like because it's a distributed database, you'll have to keep it updated. Whereas the smart driver and connection pool combo auto updates that list, right? So, so for these reasons, there's and the third thing, of course, is as Shawn said, you have to explicitly configure PG bouncer in a session mode, a transaction mode, in a variety of different modes. So for these reasons, what we're doing is we're building in a PG bouncer equivalent into the server side of YugabyteDB. So every node comes with its own, PG bouncer like native functionality. So you don't have to do explicit external authentication. You don't have to, worry about figuring out the mode to run it because it already understands, should the connection be sticky? Should the connection, can it be round robin, et cetera, et cetera. So I think, is it a pinned connection, so to speak, or not? So we're putting all of that into the server side to make it really easy, because scale and distribution and multi-node is really a core ideology here. So hopefully that answers your question, but great question. All right, folks, I think that brings us to time. Thank you so much for your questions. I think this was very interesting and exciting demo. Thanks, Shawn. Really simple the way you showed it, and I learned something, which is good. Hopefully you guys liked it as well. Do let us know how you liked it. Do let us know if you have questions. You can once again drop it in on the LinkedIn comment box, or you can join our Slack. You can see the Slack URL on the screen, yugabyte.com/Slack. And thanks, folks, and join us for a future YFTT. Is there in a couple of weeks. Once again, we'll be talking about a number of these type of technical topics. These are talks for engineers by engineers. And thanks a lot, Shawn, for preparing and presenting. It was fantastic.
Oh, thank you.